Alright, this is Chapter 9, Lesson 6, Area of Composite Figures. So we actually saw a composite figure during the last lesson when we were solving for an area of the perimeter of a rectangle and a trapezoid, or the area of a rectangle and a trapezoid with that figure. So that's actually what a composite figure is. A blank is a figure made of two or more two-dimensional figures. So in that blank, you're going to write composite figure. So a composite figure is a figure made of two or more two-dimensional figures. So here's actually a couple of examples of what a composite figure might look like. So again, a figure that's composed of a variety of two-dimensional shapes. Composite figures often split into their component shape to calculate area. So you can see here, I have a rectangle and then a trapezoid, which was actually split into a triangle and another rectangle, another triangle. We have this one here, which is split into a rectangle and a semicircle. This figure has been split into multiple triangles and rectangles. Rectangle, a square, and a rectangle. Rectangle and two triangles. And the hexagon was split into 6 equilateral triangles. So when we're finding the area of a composite figure, you can decompose or break apart some trapezoids into a square and a triangle to find the area. So this is the most common use of this. So again, area of the square and the area of the triangle. Okay, if you don't want to memorize the formula, A equals 1/2 height times base 1 plus base 2. Okay, it'll give you the same exact thing though. So I find the area of the square, which is 3 and 3, which is 9, and the area of a triangle, 2 times 3 times 1/2, or 3. And I add the area of the square to the triangle, so 9 plus 3 is 12. You can find the area of composite figures using the same strategy. To find the area of a composite figure, I separate into figures of areas that I already know how to solve. So if you know how to do triangle, you know how to do squares, you know how to do rectangles, parallelograms, all of that, okay? Then you add the areas together. So, for example, find the area of the figure at the right. So I look at this figure. I see a rectangle right there, and I see a triangle, okay? I know how to find the area of a rectangle, and I know how to find the area of a triangle. So that's what I do. The figure can be separated into a rectangle and a triangle. I find the area of each. So I have 6 times 10, which is my rectangle, and then 4, because this area is 6, so this has to be 4, because 6 plus 4 gives me 10, okay, times 4 times 1/2. So 4 times 4 is 16, times 1/2 is 8. So I have 60 plus 8, or 68 square inches. Remember to use your units. For number 2, find the area of the pool's floor. So again, I have this little tiny trapezoid over here in this big giant pool. Okay, so I can separate into a rectangle and a trapezoid. 28 times 14 gives me 392. The area of a trapezoid is 1/2 times 2, which is the height, times 4 plus 6, which is base 1 and base 2, which gives me 10. So 392 plus 10 is 402 square feet. Again, you're finding areas, so everything's squared. Okay? You can also find the area of overlapping figures. Okay, so this is probably the hardest thing that you have to do when you're finding areas of composite figures. Okay, because you have to remember what you found and then subtract stuff. So I find the area of the figure at the right. So I can see that I have 2 squares, right? Now there are a couple different ways to do this. I can either figure out what the area of just this little rectangle is, or I can find the area of the 2 figures and subtract. Okay, so that's what overlaps. So if I find the area of the square, 12 times 12 is 144. The rectangle is 15 times 12, which equals 180. The sum is 324. Okay, the overlapping areas, this is where it becomes a little bit more difficult. So I have 6 and 8. So that means this has to be 6 because 12 minus 6 is 6, and 15 minus 8 is 7. So my rectangle has to be 6 times 7 is 42. So the overlapping area is 324 minus 42 equals 282. So that's the area of the entire square figure, not including the overlapping. If I just added the 144 plus 180, I would have counted this rectangle twice. That's not what we wanted to do. Okay. All right, there are a couple of try it problems out below. I want you to go ahead, pause the video, try them out, and when you're done, we'll go over the answers together. All right, now that you've had a chance to try out the try it problems, let's go over the answers together. So, letter A says find the area of the composite figure. So looking at this, I can break it down into a couple of different things. Okay. I can break it down here, which will give me a rectangle, a rectangle, a triangle, and a triangle, which is actually probably the easiest thing to do, because if I had this entire rectangle, which you can do, I have to add an additional 3, okay? So for this rectangle, I have 8 times 4, which is 32. This rectangle is 3 times 4, which is 12. The triangle is 3 times 3 times 1/2. And there's 2 of them, but they're different sizes. Okay? 3 times 3 is 9, times 1/2 is 4.5. This triangle is 3 times 2 times 1/2, or 1/2 times 3 times 2, which is going to be 3. And then I add them all together. 32 plus 12 is 44, plus 3 is 47, plus 4.5 is 51.5 feet squared. So area is 51.5 feet squared, or square feet, whichever way you'd like to do it. Okay. For letter B, find the area of the composite figure. So they actually already broke it down for us. So I have a square and 2 triangles. Okay, so my square is 2 times 2, which is 4. My triangle, 2 times 2 times 1/2, or 1/2 times 2 times 2, which is 2. And then another triangle of the same dimension, also 2. 4 plus 2 is 6, plus 2 is 8. So I have 8 units squared because they didn't actually give me any specific units. Okay. Letter C says find the area of the composite figure. So again, I have a rectangle and a triangle. So my rectangle is 16 times 7. 6 times 7 is 42, carry the 4, 7 plus 1 is 7, plus 4 is 11, so 112. So 16 times 7 is 112. Okay. Then my triangle is 13. I don't know what my base is, so 16 minus 8 gives me 8, so 13 times 8 times 2. Which is really like saying 13 times 4. Which is 12, 52. So 1/2 times 13 times 8 gives me 52. Then I add these together. Gives me 164. So area is 164 centimeters squared, or squared centimeters. For letter D, it says find the area of the composite figure. So again, we have something that overlaps here. So the area of this square right here, 6 times 7, is 42. The area of this rectangle is 6 times 8, which is 48. So I add those together. 42 plus 48 is 90. Then I have to find the area that I'm missing, or that's overlapping. So this length right here is 7 minus 2, or 5. So I have 5 times, and this is 1, so 8 minus 1, or 6 minus 1 is 5, which is 25. So I do 90 minus 25. So when I do that, I have to borrow. 10 minus 5 is 5, 8 minus 2 is 6, so 65. 65 feet squared. Okay, so again, I took, here's my first area. Let me actually get 2 colors to do that, so you can see. So here's my first area, the 6 times 7. So there's the first one. Okay. And then the purple, okay, that's 6, 8. So where it overlaps is where I wanted to cancel stuff out. So I'm looking at this one. So that's 6 minus 1, so that's the 5. That's this area right here. Right? That's where I got the 5 from. And then this one right here, which belongs to this, the 7 and 2, is also 5. Okay, so that's where I got the 5. All right, and that is the end of Chapter 9, Lesson 6.